Welcome to Web Handling. My name is Dave Royston. While hydraulics are not for everybody, they do have many advantages over pneumatics. Even if you do not use hydraulics, you will learn useful best practices that apply to both fluid control methods in this short clip. Pneumatics are clean and cheap, and for those reasons more common. Yet, hydraulics offers many advantages. They are strong, fast, positionable, stiff, and most important for web handling, precise. What many people do not know, however, is that you can get some of these benefits by going air over oil. This is a simple rebuild that preserves the simplicity and investment in your pneumatic piping, yet can provide the muscle and vibration reduction of hydraulics. Question: what is the definition of a seal? Answer: a place for leaks. This is one objection many people have to hydraulics, because leaks are messy. However, what a lot of people don't know is that air leaks are expensive. Very expensive. The cost of air compressors in many plants are usually second only to the cost of heating it in the winter, and usually more expensive than other utilities such as electricity. Seriously, leaks happen because you, the designer, or you, maintenance, let them happen. There are leak-free fittings and there are leak-free maintenance practices. Most particularly is to not over-tighten fittings. Hydraulics are much stronger than pneumatics. More than 10 times as strong. This is, in part, why they are also more precise. While pneumatics have a repeatability and resolution of perhaps 1%, hydraulics are notably better, as you can see for these typical specifications. Also, the lubrication of the piston seal on hydraulics is ensured and much better. Thus, the two sources of control aspects of variability are both improved. Pressure regulator resolution is proportionally better. Seal friction is reduced. As we stated in the last clip, you can't position pneumatics mid-stroke with any sort of precision or repeatability. However, you can position hydraulics quite precisely, to the thickness of a human hair, if they are equipped with a precision stroke sensor, such as a tempesonic probe, and if the assembly is stiff. If so, you may not need to always externally time the two ends of a system, and that greatly reduces mechanical complexity and, most important for control quality, friction. However, if you do this, you will need to have a redundant shutdown sensor to monitor to two sides in case of a sensor failure. There is one situation where hydraulics are very helpful. That is, the vibration that sometimes occurs on winders running bouncy grades. This subject is far too deep to cover here, and I've written and taught on this elsewhere. To make a long story short, one of the most universally helpful vibration treatments is to go from air to oil, or air over oil. The mechanism is not hydraulic damping or dampening or shock absorbing as some think. Rather, it is that hydraulics are 1,000,000 times as stiff as pneumatics. It is also possible to do active vibration reduction by feeding back high-speed pressure waves 180 degrees out of phase with the measured vibration. This is possible because some makes and models of controllers have better than 1 millisecond response. This has been researched and reported on in the literature several times, and I've personally seen a winder thus equipped. You can take entire short courses on hydraulics, such as provided by e4training.com. So I will just offer a few of my favorite best practices here. Perhaps you can add others in the comment section below. Let me finish with a couple of common myths that I've run into scores of times. That is, the belief that fixing a piston seal will somehow fix a loading problem. While I'm obviously not going to try and discourage fixing leaks or anything that is broken, it will almost never affect load quality until the regulator flow is maxed out. What will affect load quality is friction from a variety of sources, as we discussed in great detail in Web 201.16a and Web 201.17a. Another myth is that hydraulic regulators are always more precise, as we discussed in the first part of this clip. However, like any instrument quality device, regulators on I2Ps and servo valves can get bound up with contamination and thus have poor response and poor repeatability. Thank you so very much for watching this module in my Plant Practical series. Please let me know what subjects you would like to hear about in the comment section below. Please like and share if you found something useful. It is support from viewers like you that have helped my all web handling channel exceed 100,000 lifetime views this summer.